Dear students, I welcome you for the today's lecture related to the classification of heat exchangers. Basically, what the heat exchangers are. The heat exchanger, that is a device that is used to transfer the thermal energy. That is to transfer the thermal energy between two or more fluids and the solid surface exists there between a solid surface and a fluid, or between the solid particles and a fluid, or at different temperatures and in direct thermal contact. So there are the different ways by which the thermal energy that can be exchanged, that is between the two or more fluids which are separated by a solid surface. It is not always necessary that every time there is a solid surface, but it can be in direct thermal contact also. That means in case of a reaction vessel, we add two liquids or we add one solid and one gas which are at a different temperature. That means they are directly coming in contact with each other, as well as they can be separated by a certain solid surface. And second thing, that not only fluids but the solid particles that can be also taken into account for the exchange of thermal energy. So whether it's a solid surface or whether they are in direct contact, or whether it's a solid particle or whether they are fluids. And one major thing is required, that is a temperature gradient, temperature difference. So this temperature difference is the most important thing to exchange the heat. Heat exchange, we are transferring the heat from the higher temperature to the lower temperature substances or the fluids. So it's a exchange is there, exchange of thermal energy, and that is why they are called the heat exchangers. Now in general, there are the very common heat exchangers they are used, that is a double pipe heat exchanger in which the two pipes are there, one pipe is there and above that the second pipe is there. So two pipes are there. From one pipe or the inside pipe one fluid is passing, and from the outside pipe, that means it is the annulus section between the two pipes, this second fluid will pass. So this is the double pipe heat exchanger. You can see in this figure the inside part, there is a one fluid which is available, one fluid that is available in the inside section, and on the outside section of that pipe, that means in the annulus section, the another fluid that is there. So this is the most simplest arrangement, that is the double pipe heat exchanger. Then there is to limit this area required or to accommodate the higher heat transfer area, we are making the compact designs, and they are your shell and tube heat exchangers. So shell and tube heat exchangers, they are including the shell, and the second thing is that of the tubes. So two important things are here, the shell and the tubes. There is one shell is there, and in this one shell the number of tubes are available. In double pipe heat exchanger, only one tube, and the another outer tube is nothing but the shell tube or the shell that is there. So here in the shell and tube heat exchanger, that is the one inlet for the fluid and one outlet for the fluid. This is for one fluid. In this case also, there is the tube side fluid is inlet and the tube side fluid, that is the outlet, and the shell side fluid in and the shell side fluid out. So there are two fluids, they are defined, that is, one is the shell side fluid and this shell side fluid, and the second the tube side fluid. That means the fluid which is moving through the tubes is called the tube side fluid, and the fluid which is outside the tubes, that means it is inside the shell, so that is called the shell side fluid. So we are having in general case the two fluids, one is the shell side and another is the tube side. Either of the fluid can be hot or cold. So there are number of tubes which are available in this shell, and these tubes are held with the help of a tube sheet. If you will see this, that is called a tube sheet. This is one of the most important parts. In this figure, there are two tube sheets. There are two tube sheets which are available. And to close this, it is the front head end or the channel cover or the tube side shell cover, or it is also called the rear end head or the end cap, that is there. In between the shell, there are number of baffles which are available, and these baffles create the turbulence for the fluid which is moving in the shell side. This is the fluid which is moving in the shell side. This fluid, when it moves, it takes or changes its direction, and as a result of this change in the direction of the fluid and changes in the cross sectional area, the velocity increases. Changes in the cross sectional area. Now in this case, the cross sectional area is this much, but in the vertical section the cross sectional area, it is reduced. So changes in cross sectional area and the changes in the direction, it creates the turbulence for the shell side fluid. The requirement of increase in the turbulence is for increasing the heat transfer rates, increasing the heat transfer coefficients. For that purpose, the baffles they are provided. So we are having the few important things, that is the tubes, the shell, the fluid, that is which is on the shell side, and the fluid which is on the tube side. For that, the inlet for the tube side fluid, the outlet for the tube side fluid, inlet for the shell side fluid, outlet for the shell side fluid. Then end caps or the channels which are provided. Then the baffles and the tube sheet. These are the most and the common important labelings of a shell and tube heat exchanger. Besides that, there are number of heat exchangers, that is the furnace, plate type heat exchangers, the spiral heat exchangers. All these are the different types of heat exchanger, and accordingly they're classified. So we'll move towards the classification based on the different types, that is according to the transfer processes, according to the transfer processes, then according to the number of fluids, according to the compact surface, then according to the construction features, then flow according to the flow arrangements, and according to the heat transfer mechanism. This is the basic important classification, that is according to the heat transfer mechanism, according to the flow arrangement, according to the construction features, surface compactness, number of the fluids, and the transfer processes. So one by one we will go into the details for each classification. So classification according to the transfer processes, first we will discuss that. Now when we are talking about the transfer processes, in these transfer processes, one is indirect contact and the direct contact. So these two are the most important thing, the indirect contact and the direct contact type heat exchangers. Now in the definition of the heat exchanger, we have seen that the two fluids which are separated by a solid surface and or they can be in direct contact with the thermal surfaces, direct contact. So based on this, the indirect contact means they're separated by a certain solid surface, and direct contact, that is they are directly contact. For example, in case of our reaction vessels, that is the fluids, they are directly mixed into one another, that is one fluid is at a different temperature, another fluid is at a second temperature. So the two fluids, they will directly mix with each other and will exchange the heat and will maintain a certain uniform temperature or the certain intermediate temperature between the two fluids. So in that case, the immiscible fluid exchangers, gas liquid exchangers, and the liquid vapor exchangers that can be there. Besides that, a continuous stirred tank reactor, all the mixers, they are also taken into account for the vessels type. So this is a direct contact. Now indirect contact type heat exchangers, where they are separated by a certain fluid, separated by a certain solid surface. In that case, the direct transfer type heat exchanger, that means a continuous process is there. Through one tube, the hot fluid is passing, and the outside of that, the cold fluid that is passing. So this is what the direct transfer type. Indirect contact category, it's a contact, whether the fluids are in contact or not. That is the first classification. And in that indirect contact type, we are having the direct transfer. That means from hot fluid to the cold fluid, there is a direct transfer, but they are separated by a metal wall. Then the storage type. In the storage type, we are storing or we are holding the amount of heat which is given by a hot fluid, and then exposing that fluid or that surface to a cold fluid. These are called the direct transfer type heat exchanger, or they are called the regenerators. Regenerators. These storage type heat exchangers, they are also called the regenerators. That means we are storing the heat. First, a certain solid block or solid mass that is exposed to a hot fluid, and then it is exposed to a cold fluid. So heated surface that is getting regenerated. That is why it is called a regenerator type. And the direct transfer type, they are called the recuperative. Recuperative. Recuperative type. So regenerative, recuperative, and third one is the direct contact type. So this is according to the transfer processes. And next is the fluidized bed heat exchanger. In case of a fluidized bed heat exchanger, there the direct transfer that can be there, or the indirect transfer that can also be there. So that depends on the arrangement of a fluid. So in this fluidized state or fluidized condition, the solid particles are in a fluid like motion. That is what is there in a fluidized bed heat exchanger. That means we are using fluidizing a solid waste and burning that solid waste. That is a direct contact type heat exchanger. However, there are certain indirect type also. That means that is a certain tube which is available, and through this tube one fluid is passing, and the another fluid or the another solid surface which is getting passed outside this. So there is a indirect type also. So first classification according to the transfer processes: regeneration, recuperation, and the direct contact type. The next is the depending on number of fluids. I can use one fluid, two fluids or three fluids, but they are not very common. Then next classification is according to the surface compactness. Surface compactness, that is the gas to fluid exchangers and liquid to liquid and phase change exchangers. So surface contact, that becomes more important in this case, where the gas is one of the component here, liquid to liquid and phase change that is there, like in case of your condensation or evaporation. So this is the phase change, you can say. The next is according to the construction feature, and this is one of the major part in case of your classification of heat exchangers according to the construction type. In that, the tubular heat exchangers are there, plate type heat exchangers, extended surface heat exchangers, regenerators, then spiral type heat exchangers. So based on the type of construction, all they are classified. So first is a tubular heat exchanger. In that, the simplest form, that is a double pipe heat exchanger, that is available. Tubular double pipe heat exchanger. Then there is a shell and tube heat exchanger where the complexity is increased, or the number of tubes inside the shell, they are increased. Compact design that is available. And the spiral tube heat exchanger, that is also there. Then next is a plate type heat exchanger. Especially plates, they are used and are separated, and through which the fluid that is passing, one fluid and the another fluid that will pass, means metal surface of the plate which separates the two fluids. In case of a shell and tube heat exchanger, your tube metal that separates the two fluids. In case of a plate heat exchanger, the plate that separates the two fluids. So in that case, the gasketed plate heat exchanger, welded and the other plate heat exchanger, spiral plate heat exchanger, lamella heat exchangers, printed circuit heat exchangers, pen coil heat exchangers, these are the different types of plate type heat exchangers. Out of this, the gasketed plate heat exchangers are the most commonly and widely used in the different types of industries, specifically in case of your food industries, oil industries, then your surface coating industries. These plate type of heat exchangers, they are more common. Next is the extended surface heat exchangers. So in this extended fin surface exchangers, extended surface, that means a fins they are provided, extra surface that is provided to the main body of a heat exchanger. main body of the tubes. So these are the plate fin heat exchangers and tube fin heat exchangers. In that there are further subcategories are also there. That is, then next is a regenerators. Regeneration, where the surface that is heated, and in that category the rotary regenerators and the fixed matrix regenerators are there. Fixed matrix regenerator, that means a matrix which is available, and initially the hot fluid that will pass through over it. As a result, this temperature increases, temperature that is increased. Then when it is hot, so the cold fluid that will pass over that, so that the temperature decreases. That is what happens in case of a regenerators. At that time, instead of using the one regenerator, I will be using the two regenerators in series, and one will be when passing with the hot fluid, the another that will be passing with the cold fluid. So this is the alternate arrangement for the regeneration charging and the discharging. That process is to be carried out. The next is the classification according to the flow arrangement. There is a single pass exchanger, multiple pass exchangers. These are the two major classifications in case of a flow arrangement, whether it's a single pass arrangement or whether it's a multiple pass arrangements. In case of a single pass arrangement, we are having the counter flow exchangers, parallel flow exchangers, cross flow exchangers, split flow exchangers, and divided flow exchangers. These are all the different types. One by one we will see their figures also. First we will understand this. This is according to the flow arrangement. That is a single pass and a multiple pass arrangement. In case of a single pass heat exchanger, we are having the counter flow exchanger, parallel flow exchanger, and a cross flow exchanger. What is a parallel flow exchanger? Both the fluids, they are in one direction. In counter flow exchanger, they are in the opposite direction. And in the cross flow exchanger, they're perpendicular to each other. They're perpendicular to each other. And split flow exchanger, that is, the flow is splitted in two ways or three ways depending on the. So I'm putting a certain plate here. This plate splits the flow. That is a split flow exchanger. Then divided flow exchanger, that means you are dividing the flow into the two or three parts. Flow that is divided. One part is here, another part is here. So it's a divided flow heat exchanger, split flow, cross flow, parallel flow, and counter flow arrangement. So this is my first parallel flow arrangement, counter flow arrangement, the cross flow arrangement, split flow arrangement. Then there is a multi-pass heat exchangers also there. In this multi-pass heat exchangers, the multi-pass cross flow exchangers, multi-pass shell and tube heat exchangers and multi-pass plate heat exchangers are also there. That means in case of a shell and tube heat exchanger, the tube side fluid or shell side fluid that is passing more than one times, multi-pass. If the fluid is like this in the opposite direction, so tube side fluid, it moves like this and changes its direction and revert back. So in this case, this is the first pass and this is the second pass. So two passes for the tube side that is available. Similarly, you can also have more than one pass for the shell side also. That is the multi-pass cross flow exchangers, multi-pass shell and tube heat exchanger and multi-pass plate heat exchangers. And lastly, the classification according to the heat transfer mechanism, whether it's a conduction, convection or radiation. That is based on the mechanism of heat transfer. So this is the different classification based on the different